An HMO has 75 doctors to be apportioned among 3 clinics. The HMO decides to apportion the doctors based on the average weekly patient load for each clinic. Complete the following apportionment table. So we have all of the clinics and their average weekly patient load listed here. And then they are also listed in this column. So the first thing I want to do is add all of these up. And if I do that, I get 2,277. I want to find the standard divisor. So I'm going to divide the total population by the number of people to apportion. So we have 2,277 divided by the 75 total doctors. And this is equal to 30.36. So that is my standard divisor. Next we are finding the standard quota. So we need to divide the group's population by the standard divisor. So I want to take each of these numbers and divide them by 30.36. And we're going to get quite large decimals, so we're actually going to round them to 3 places. And if you do that, you should get 11.199, 12.516, 20.455, 24.605, and 6.225. And if you add these up, you get 75, because we have 75 doctors. Now, if it didn't add up to be exactly 75, that would be okay in this column, because we had to do a little bit of rounding on these numbers. Next, we are finding the lower quota. So we want to round down the standard quota. So each of these numbers I want to round down. So 11, 12, 20, 24, and 6. And these add up to be 73. So that's okay for this column, but we do need to take a note that we are going to need 2 more. Next is the upper quota, which says we need to round up the standard quota. So each of these numbers we now want to round up. And that should get you 12, 13, 21, 25, and 7. And these add up to be 78, which is more than the 75 doctors that we have, but that is okay for this column. Now we are completing Hamilton's method. So we need to initially give each group its lower quota, then give surplus items one at a time to the groups with the largest decimal parts in their standard quotas until there are no more surplus items. So initially we are starting out with these numbers: 11, 12, 20, 24, and 6. And these add up to be 73, but because we have 75 doctors, we need 2 more. So we want to look at the numbers in the standard quota column and then find the numbers with the largest decimal part. So the largest decimal part is 0.605. So that means Clinic D gets 1 extra doctor. So that's now 25. The next largest decimal is 0.516. So Clinic B gets 1 extra doctor. So that's now 13. And then if we add these up now, this equals the 75 doctors. Now we are starting over with Jefferson's method. So we need to divide the group's population by the modified divisor and then round down. So I'm going to take each of these numbers and divide them by 29.5 and then round down. So that should get you 11, 12, 21, 25, and 6. And those add up to be the 75 doctors. Now we are starting over again with Adam's method. So we need to divide the group's population by the modified divisor and then round up. So I'm going to take each of these numbers and divide them by 31.3 and then round up. And if you do this, you should get 11, 13, 20, 24, and 7. And these add up to be 75. Lastly, we are looking at Webster's method, which says we need to divide the group's population by the modified divisor and then follow traditional rounding rules. So if the tens place is 5 or greater, you want to round up the number. So I'm going to divide each of these numbers by 30.4 and then follow traditional rounding rules. And you should get 11, 13, 20, 25, and 6. And these add up to be 75. So as you can see, the 4 different methods sometimes distribute the doctors the same and sometimes differently.